All right. So I've been asked to cover some quiz 4 material. So I'm going to go over the basics for quiz 4. We'll just see how we feel after that. And then we're going to jump into quiz 5 because I was also asked for a little bit of quiz 5. All right, so when it says evaluate each of the following when x is negative 1 and y is 8, it's just saying that instead of x, we can replace it with a negative 1. Now, whenever we replace something, we're going to replace it in parentheses. So x is some value, right? That's our x value. And y is some other value. So right now we have whatever x is minus 2 times whatever y is. And so if we plug in those values for x and y, again, doing so in parentheses, we know that x is negative 1. And we know that y is positive 8. And these parentheses are important. If they aren't there, you might miss a double negative sign. We'll talk about that later. We get negative 1 minus 2 times 8. Well, 2 times 8 is 16. And so we get negative 1 minus 16. And that'll come out to negative 17. So there's our evaluation of x minus 2y when x is negative 1 and y is 8. We can do the same thing down here. Again, x is still going to be negative 1. Y is still going to be 8. I apologize for the shadow. Let's see if I can get rid of a little bit of it. It's that time of the day. We have 3 times whatever x is. And we're timesing it also by whatever y is. Well, we know from above that y is 8. And that x is negative 1. And again, we're just multiplying here. That's what 3 times x times y means, 3xy. When we do that, we get negative 3 times 8, which is negative 24. Down here, still using x is negative 1 and y is positive 8. We have 2 times x times y squared. Now remember, y squared means y times y. So y is going to be multiplied by itself. Same thing here where x is going to be multiplied by itself. So we have x squared times y. So 2 times x times y squared. And again, that square is only affecting the y. And then we have x, which will also be squared. And we're timesing that by whatever y is. So now that I've got this set up, I can plug in my values for x and y. Remember, y is positive 8 in this problem, and x is negative 1. That's what they told us at the beginning in the directions. And so now we just multiply across. This means 2 times negative 1 times 8 times 8. So we can do it in any order we want. I think I'm going to do negative 2 here times 8 once, which gets me negative 16, times 8 again, which is going to get me negative 256. And then I've got negative 1 squared. Well, negative 1 times negative 1 is 1, and 1 times 8 is just 8. So we're going to get negative 248. So this is the first problem set, the basic questions on chapter 4, A, B, and C. And as mentioned previously, our paper towards the end of the year isn't very good, so there's going to be a little bit of bleeding. We can work around that. The next problem is 421, part A and B, and we're just combining like terms, right? They want us to add for both of these. So we're just going to add terms that are alike. So I have 3 b's and I'm adding negative 5 b's. Those are like terms. They can add together. 3b minus 3a's, they're apples and oranges. We're not allowed to combine those. But 3b plus negative 5b is negative 2b's. And I can also combine the negative, don't forget to keep that negative with it, negative 3a, and I'm adding 3a. So negative 3a plus 3a, well, anything that's like opposites like that, negative 3a and 3a, if we add them, we're going to get 0, right? It's kind of like negative 3 plus 3. It's going to get a 0. So we have 0 a's. And you could write, if you wanted, plus 0 a's. But think about what this means. This means negative 2 times b. Okay. But this means plus 0 times a. Well, it doesn't matter what a is. Because as long as we have 0 times anything, we're just going to get 0. So this whole thing right here is really just 0. Well, what's negative 2b plus 0? Well, anything plus 0 is just itself. So really, we could have just written negative 2b, because this part becomes 0. It goes away. Down here, combining like terms, be careful. Remember, we're going to combine z's with z's, y's with y's, and x's with x's. So here's 3z's, and here's negative 9z's. Again, don't forget to bring that negative with it. We've also got negative 10y's, and we've got positive 4y's. And last but not least, we have our x's. We have 8x's, and then another 8x. And if we were subtracting these, they would definitely become 0, right? 8x minus 8x, but we're not. We're adding. So we're going to add them. So let's do our z's first, just because it's the first thing here. 3z plus our negative 9z is going to get us negative 6z's. And if we're adding negative 10y and 4y, we'll get negative 6y. And because we're adding 8x plus 8x is going to be 16x's. So that's simplified because we have reduced it from 1, 2, 3, 4, 5, 6 terms down to just 3. And the rest of them we can't combine, right? Z's, y's, and x's aren't like terms, so they have to remain separate. Now it's going to say simplify this, and this is multiplication, right? That's what's happening here with all these dots. So we have x times x, and then we've got another times x later on, and it doesn't matter what order we multiply in. So I could write this as x times x times x times x. Well, that's x to the 4th, using that superscript. And if you count the number of y's that we're multiplying together, we have 2 y's being multiplied, so that's going to be y squared. And we're supposed to multiply 3 z's together. Well, z times z times z is just z cubed, or z to the 3rd power. So we're still multiplying 4 x's, 2 y's, and 3 z's all together. We just arranged it a little bit better. Over here, it's the same concept, except we have b's. And they've already grouped up a bunch together for us. So we have 8 b's being multiplied, 9 b's if we include this, and 12 b's total being multiplied. So that's b to the 12th. Using the same logic with the a's, we've got a times itself twice, times itself 4 times. So we have a times itself twice, times 4 more a's, a total of 6 a's being multiplied. So this is b to the 12th, meaning b times itself 12 times a times itself 6 times. And that's exactly what this is. We've just arranged it a little bit better by combining like terms. For 4.3.1, it says expand the following. By expand, what we mean is instead of creating less terms like we were doing in the above problems, right, trying to reduce this down, what we're going to do is we're going to expand this to multiple terms. Right now, we've got negative 3 times 1 term, and it's 1 term because it's all in parentheses. That's what parentheses do. They say treat this like 1 term. Normally, a term is anything separated by a plus or a minus, which is why we had 1, 2, 3, 4 terms here, right? But those parentheses tell us treat it as if it's 1 term. So we have negative 3 times this thing. So that's all 1 term, this thing here. And what this means is we have 3 times this. So if I have 3 of these things, I'm not going to have 2 r's, I'm going to have 6 r's. And I'm not going to have 8 s's, I'm going to have a total of 24 s's. So one of the things that we notice is that you can do this thing, and it'll tell you how many total r's and s's you'll have if we were to times it by 3. And of course, we're timesing by negative 3. So we're going to get negative 6 r's, because we're multiplying. And that double negative is going to make a positive 24 s's. And it's expanded because we went from 1 giant term to 2 separate terms. Over here, using the same logic, we're taking this whole term and timesing it by this whole term. Well, of course, there are pieces inside here. So we can multiply each individual piece by negative 2x. Well, 5 times negative 2 is negative 10. And x times x is x squared. Over here, we've got negative 2 times 7, which is negative 14. And x times y is just xy. Then we've got a positive 6xz, because that's what x times z is, and that's what negative 2 times negative 3 is. Notice that none of these have like terms. That's xz, that's xy, that's x squared. So we can't reduce it anymore. We're just going to leave it like that. 4.3.2 says simplify the following. And a lot of people miss this, especially after doing the last one. This is telling us to subtract. So it's very similar to this last problem up here and here, except instead of adding them, we're going to subtract them. So let's combine like terms. Well, I can combine my x's x and 6x. And if I do that, x minus 6x is negative 5x's. Then over here, negative 5y minus negative 8y. Well, if I'm minusing a negative 8y, I'm really adding 8y to this negative 5y. So I'll get a positive 3y. And again, neither of these can be combined, so I can't simplify it any further. There we go. This is the same as all of that. Almost done with the basic questions. It says factor each of the following. So factoring is kind of the opposite of what we were doing here, expanding or distributing, which is what this thing is, right? So we're going to go from here, basically, back to the original problem. Notice that both 6 and 24, our two terms here, have a negative 3 in common. We could pull out a negative 3 from both of these, making 2 and negative 8. Same thing here, we could pull out an x from everything, and we can also pull out what looks to be a 2, which is exactly what they did earlier. So when we factor this out, what we're trying to do is turn this into a multiplication problem. Right now it's addition. What do both these terms have in common? Well, they both have a negative 10 inside them, and we can take that out. So I can rewrite this problem as negative 10 times x, because that's what this is, right? And if I were to distribute it back, I would need a minus 3y here, because negative 10 times negative 3 gets me my positive 30. So this and this are the exact same thing. And now it is a multiplication problem. Something times this thing. That's factoring. You just have to think about what common multiple is between all this stuff. If there was another x over here, I could have pulled out an x as well. But of course there wasn't. Down here it says, how many copies of this must we add together to get this? Well, if I add 2 copies together, I'll end up with 10 x's and negative 14 y's. So not quite. But you might notice that if I add 7 copies of this, 5, 10, 15, 20, 25, 30, 35, I'll get 35 x's. And I'll get 7, 14, 21, 28, 30, 35, there we go, 42, 49 y's. So we need 7 copies. And the way you can check that is by thinking of this. 7 times this guy. Does it equal this? Well, it definitely does. If we distribute, we get 35y, or 35 x's. And we get negative 49 y's. So yep, 7 copies. Right, this is a single fraction. So this is a little bit of pre-algebra stuff, except now we're doing it with variables. So we need common denominators. Right now we can't just subtract those. So we need them to match. Just like if I had 3/4 minus a half, I couldn't subtract that because quarters and halves are different things. But if I were to multiply this side by, let's do 4 over 4, and this side by 2 over 2, I would get some fractions that do have common denominators. Now notice, when I multiply by 4 over 4, I'm really multiplying by 1, because 4 divided by 4 is 1, and multiplying by 1 won't change my number. It'll just make it look different. And that's what we get. 1 times 4 is 4, 2 times 4 is 8, and notice that 4/8 is the same thing as a half. So I didn't change this number, I just made it look different. And over here, we're also going to get 8ths, and it looks like we're going to get 6 of them. So when we subtract, we're going to get 2/8, which you could simplify to 1/4. So the whole point of getting common denominators is so that we can see how many we have left over. 3/4 minus a half is hard to tell what we have left over, but 6/8 minus 4/8 is clearly just 2/8. So that's what common denominators are all about. And of course, we could simplify that to 1/4. So for this, we're going to use the same idea. If I take 8 over y minus 3 over x, one way to get common denominators, as we saw earlier, is kind of multiply by each other's denominators, right? We still have to multiply by 1, otherwise it'll change the problem. But this gives us a hint of how we might solve this. If I multiply by x over x, notice that is 1. Anything divided by itself is 1. And I multiply this term by y over y. Oh, let's flip that. X over here. Y over there. Again, still multiplying by 1. What we'll end up with is 8 x's in the top and x times y in the bottom. And then we'll have minus 3 times y in the top and x times y in the bottom. And notice now they have common denominators. So I have 8 of these minus 3 of those. And what we get is 8x minus 3y all over xy. Just like here, we could have written 6 minus 4 over 8. But of course, we simplified this. 6 minus 4 is just 2. Here we can't combine them because they're not like terms, but here we could. 6 and 4 are easy to combine. 6 minus 4 is 2. 8x minus 3y, well, it's just 8x minus 3y. So again, getting those common denominators is key, and once you have it, you can write it all over the same denominator. Last but not least, we have 4.51. Consider the equation x over p minus m equals n. We want to solve for x in terms of the other variables. So that means we want to get x on its own, and we're going to have a bunch of stuff with like m in it, and p in it, and n in it. And as long as there's no x's or any other variables other than m, p, and n, then we've done it. X on its own with m, p, and n over here. So let's just start with the equation they gave us, which is this. So notice I want to get x on its own. So I need to make this 0 so it's gone, and I need to get rid of the p without getting rid of the x. Now there's lots of ways to do this, but in order to make negative m 0, we have to add m. The other thing is we could times everything by 0, but that would make everything go away, so you don't want to do that. Adding m, we'll get rid of that. Now of course to add m and get rid of this, that would change the problem, unless we add m to both sides. So we get x over p, that becomes nothing, equals n plus m. Now x is not completely on its own. It's not solved in terms of m, p, and n. In fact, there's no p in this at all. So what we need to do is we need to get rid of this divides by p. Well, to get rid of division, we can multiply, because we can times by the top or divide by the bottom first. And when we divide by the bottom, anything divided by itself, again, p divided by p will be 1. You might say, well, I thought we were timesing. We are, but not yet. If we do p divided by p first, we get 1, and then 1 times x is just x. So we can multiply or divide in any order. I chose to divide first. P divided by p is 1, and then I'll times later. 1 times x is x. So of course, doing this changes the problem unless I times all my other terms by p as well. When I do that, I get pn plus pm. And now x is in terms of m, p, and n. Down here, it wants us to get m in terms of the other variables. So using the same equation, we have this. Well, notice that I want to get m in terms of the others, not negative m. So right now I have a negative m. So one thing that you could do is you could add m, which would eliminate it from this side. And of course, naturally, we have to add it to both sides. Otherwise, we've changed the problem. And now we get a problem that looks like this. So at least now we have positive m. And now, to get m on its own, really all we need to do is make that n 0. We know how to do that. Minusing n from both sides will not change the problem, but it will allow us to get m on its own. So on this side, we just have m, because this becomes 0. And x over p minus n, they don't have common denominators, so I can't combine them, but I can write it like that, this minus this. And now we're done, because m is in terms of x, p, and n, and it's on its own. Those are the basic questions for quiz 4. I think due to time, I think I'm just going to look at some of the basic questions for quiz 5. Let's consider this equation. And remember, equations are just patterns, right? So like an equation like this means that there are two numbers, x and y, and they always obey this pattern, where y is double of x. So if x were 1, y would be 2. If x were 3, y would be 6. If x were 10, y would be 20. So all of these pairs of numbers obey that pattern. Now this is a more complex pattern, right? 8 times x minus 5 times y, whatever numbers you plug in for x and y have to, after doing all this, equal 13. But we're not so concerned with the pattern right now. It says solve the equation for x in terms of y. And I think this works well with the last problem we were talking about, because we know x in terms of y means get x on its own and have it equal something with y in it. No other variables are allowed. So how do we get x on its own? Well, one way would be to get rid of this completely, right? We need that completely gone. And to do that, we add 5y to both sides. So what we end up with is this becomes 0 because I added 5y. And now, since I added 5y to this side, I have 5y plus the 13 that's already there. Now this isn't solved for x, it's solved for 8x. So if 8x is this, then one might conclude that 1x is just this divided by 8. So I divided by 8 to both sides. This thing all gets divided, and that becomes 1. 8 divided by 8 is 1. 1 times x is x. This whole thing divided by 8 we can write like that. You can also divide each of these terms individually. Divide the 5 by 8. And of course divide the 13 by 8. So either of these will work. I usually just do this. Same problem, except now we're going to get y in terms of x. So we're going to want something like this. To do that, I don't want to get rid of this. What I do want to do is get rid of that. So I'm going to subtract 8x. When I do that, I'll end up with my negative 5y still, minus the 8x's that I did to this side, which gives me 0, and then to this side, which gives me negative 8x, plus the 13 that's already there. And of course, to get rid of that negative 5, I'm going to divide everything by negative 5. Dividing this by negative 5 gets me 1. 1 times y is y. That's why I did it. Gets y on its own. And then I'm going to divide every other term on this side by negative 5. And I can do that just by putting a giant division bar. 512 says find 3 ordered pairs that satisfy this equation. So here's a pattern, right? We want numbers that when you plug them in, do this. And remember what this means. This means 3 times q minus 2 times p gets 2. So I'll make a chart. I'll write q first and p next. And we want 3 pairs of numbers, right? That obey this pattern. Well, if I plug in 2 for q, that means 3 times 2, which is 6. And if I plug in 2 for p, I get 2 times 2, which is 4. And of course, we're supposed to subtract them, and that would get me 2. So this is a valid solution. Another solution I can get, right? This is kind of like multiples of 3. 3 times 1 gets me 3. 3 times 2 gives me 6. That's what we just used. 3 times 3 would be 9. 9 minus 7 gets me 2, but I can't make that 7 without fractions. Some of you guys are okay with using fractions, but if you want to use whole numbers, we'll skip that. So 3 times 3 is not going to work, but 3 times 4 gives me 12. And if this is 12, I need this to be 10, because 12 minus 10 gets me 2. So how can I make this 10? Well, 5 times 2 is 10. So there's our solution. 4 and 5 for q also gets us 2, because we get 12 minus 10. Now, once you've already found 2 sets, you can use slope to figure out the next. And slope is really just the pattern that's happening here. Notice that we added 2 to get to 4, and we added 3 to get to 5. If we continue that pattern, we should find another solution that also makes our pattern true. Well, if we add 2, we get 6. If we add 3, we get 8. And if we check that, 6 times 3 is 18. And 8 times 2 is 16. So it is true. When we plug 6 and 8 in for q and p, we do get a valid solution with this pattern. Finding a solution like that with 2 different patterns, 2 different equations, is tough, right? What numbers work with this pattern and work with that pattern is what they're asking. So we have a strategy. In fact, we have 2. And I'll show you one of them. To solve a problem like this, it's much harder to just play around with the numbers, because sure, we might find some numbers that work with the top, but finding numbers that also work with the bottom, again, the same numbers that work with both, is going to be a very difficult task. So we're going to use something called substitution. And that's a method that I can actually best show you down here. So all 3 of these kind of work the same way. I'm going to show you down here what this looks like. And because it's bleeding through, I think I'm going to cover this up with a piece of paper. So substitution is replacing stuff. Now we did that earlier, right? When we were evaluating on quiz 4. Let's see if I can find that. Here, we were substituting -1 for x. We were substituting 8 for y. Because it told us y is 8, so wherever we see a y, we can replace it with an 8. So here, they don't tell us what x and y equal, but we can rearrange this equation. So we get x equals some stuff. In fact, we're going to get x in terms of y. So similar to the first page on quiz 5. So if I take this equation, x plus 5y equals 17, and I get x on its own, the way I would do that is subtracting 5x from both sides. Or sorry, 5y from both sides. That'll eliminate this. And we'll get 17 minus 5y. Hope I gotta shut the door. So another way of thinking of this pattern is like this. They're the same pattern, it's just a different way of looking at it. But now, if I told you x was 17, you could plug that in wherever you see an x. Well, we're going to take this one step further. I didn't tell you x was 17. We figured out that x is equal to 17 minus 5y. So wherever we see an x, we can replace that with 17 minus 5y. They're interchangeable. They're the same. That's what equal sign means. So I'm going to plug that into the equation I didn't get this from. I got this from the top. So in the second equation, I'm going to rewrite it as 11 times whatever x is, again, plugging in parentheses, plus 8y equals -1. And we know x is equal to 17 minus 5y. So instead of 11 times x, I'll write 11 times 17 minus 5y. Using some of the skills we acquired in Chapter 4, we're going to distribute this 11 into both of these, right? There's two terms here. 10 times 17 is 170. So 11 times 17 is just 17 more than 170, also known as 187. 11 times -5y is definitely negative. It'll come out to -55y's. Combining like terms, again, using some skills from Chapter 4, -50y's plus 8y's, we can combine those because they're both y's. And we'll end up with a total of -47y's. If I subtract 187 to combine it with this -1, I get -188. And so now we've got a problem that's much easier to figure out what y would equal. We need something times 47 to get 188. Well, if I had to guess, I would think that 4 times 47 gets me this, because 4 times 40 is 160. That's pretty close. Also, 4 times 7 gets us 28, which ends in an 8. So it's a good guess that y would be 4, and it turns out it is. 160 and 28 makes 188. So we solved for y, and we found out that the y that works for both of these has to be 4. So what does x need to be? Well, if we know x is equal to 17 minus 5y, and we know what y is, then we know that x is equal to 17 minus 5 times 4. Well, that's 20. 17 minus 20 is -3. So the winning combination that works for both patterns is when x is -3 and y is 4. And if we check that by plugging it in, you'll see that that's true. When x is -3, I get -3. When y is 4, I get 20. -3 plus 20 is 17. If I check it in the bottom equation, because again, it should work for both, it fits both patterns. That's what makes this special. -3 times 11 is -33 plus 32. -33 plus 32 is -1. This is in fact the only pair of numbers that fits both patterns. I can apply that to the equation below, but I can also apply that to this equation above, because they're all just asking what pattern or what pair of numbers works with both patterns. Here it was easy to get x on its own, but we could get x on its own in this situation, or y, or any variable we wanted. Let's say we wanted to get x on its own for this equation. We'd add 3y and divide by 2. Adding 3y and dividing by 2 gets rid of everything we don't need, and there's x, which we would then plug into the other equation here. You'll notice when we plug this in, that 2 times x, this being x, these 2's divide out. 2 divided by 2. We don't have to distribute first. We can divide first, because remember, we can multiply or divide in any order we want. So if these divide out, what we end up with is just -4 plus 3y minus 5y equals 4. And you can reduce that until we get y on its own, and we'll figure out what y is, plug that back in, and get x. And that will solve this problem. Same thing down here. Maybe you want to get y on its own in the top equation. The way we would do that is just divide everything by 10. So dividing by 10 gets me 1y, and then dividing all this by 10 gets me this, which I could then plug in for y in my other equation. And if I plug this in for y, you'll notice that while 5 and 10 don't divide out, 5 divided by 10 is a half, right? 5 divided by 10 is a half. So basically we're taking half of 4x plus 8. Well, half of that's just 2x plus 4. In this situation, we could get all our x's together, solve for x, use that to find y, and then we'd have our pair that works for both. That's the substitution method. They call it substitution because we're switching stuff out, right? We switched out y for what it is. Looking at 522, we're going to use a little bit of substitution. It says, suppose that we know x is 5 minus t, and y is 2t minus 1. It's saying if x is 1, okay, well, if x is 1, then I know this. X is 1. What will y be? Well, notice this doesn't say anything about y, but we could figure out what t is. 5 minus what is 1? Well, 4. T must be 4 if x is 1. And if t is 4, well, I know that y is in terms of t. So if I think about it, y is 2 times t, which is 2 times 4, minus 1. So that's 8 minus 1, meaning y would be 7 when x is 1. So if x is 1, t has to be 4, and if t has to be 4, well, then y has to be 7. If x is negative 1, pull this back down, then I know this is true. Well, 5 minus what gets me negative 1? Well, 6. So that means if x is negative 1, t is 6. And if t is 6, then y is going to be 11. Because 2 times 6 minus 1 is 11. Now it says find y in terms of x. So that means we need to get y equals a bunch of jump with x in it. Right now we have y in terms of t. So here's what we're going to do. I'm going to replace that t with something with x in it. So how can I get t in terms of x? Because if I know t equals a bunch of junk with x in it, then I can take that stuff and substitute it in. Again, I'll say that again since it was off screen. I'm going to get t in terms of x. Because then I'll be able to plug in something with x in it and have y in terms of x. So what is t in terms of x? Well, I know x in terms of t. So if I play around with that, I can get t on its own by adding t to this side. Adding it here gets rid of it. And subtracting x gets me this. That is t in terms of x. So instead of thinking 2 times t minus 1, I can think of y as 2 times 5 minus x, because 5 minus x is t minus 1. With distribution, I get y equals 10 minus 2x minus 1, which means y is going to be, when I subtract 1 from 10, 9 minus 2x. That's y in terms of x. For 531, it says solve each of the following systems of equations using either substitution or elimination. Again, these are 2 patterns. The question is, what numbers fit both patterns? And we can do substitution like we used before, or elimination. Now, elimination is a method we haven't talked about yet, so I think it's good to demonstrate it here. Elimination is called elimination because it eliminates one of our variables. So we're going to get one equation that only has one variable in it, which is going to allow us to solve for one of those variables and then find the other. So I'll show you what I mean. Right now, if I were to subtract these 2 equations, 6x minus 6x is 0 x's. And of course, 0 x's is just 0. So it goes away. It got eliminated. Negative 4y minus 3y, because again, we're minusing here. That's how we got rid of this. So we got a minus here. Negative 4y minus 3y will get us negative 7y. We've got an equal sign. Negative 20 minus 15 is negative 35. And then the question becomes, what times negative 7 is negative 35? 5. So we know the winning combination for both of these is y equals 5. What is x going to be? Well, if we know y is 5, I can rewrite the bottom equation as 6x plus 3 times 5 equals 15. And because 3 times 5 is 15, the question becomes, what number plus 15 gets me 15? Well, of course, 0. What times 6 is 0? 0. So the winning combo is when x is 0 and y is 5. And if we check that, it checks out. If x is 0, this is nothing. 0 times 6 is nothing. And then y is 5, we get negative 4 times 5, which is negative 20. Checking in the bottom equation, because again, we need a solution that works for both. That makes it 0. That makes it 15. 0 and 15 is 15. So elimination can be quick. Although sometimes you'll get a problem that you want to do elimination for, and you'll notice that none of the stuff when we add or subtract would make it go away. If I were to add or subtract, my u's wouldn't go away. I'd either get negative 7u's, or what I'd get is negative 1u. So that doesn't go away. It doesn't get eliminated. Same thing if I were to add my v's up. Notice they're not aligned like this one is. So if you want to, you can rearrange these to make it a little bit easier to solve. What I think I'm going to do is I'm going to multiply the top equation, every single term, by a number so that it matches the bottom. And I'm going to do that by multiplying both the top and the bottom by a number. And the easiest way to do this is kind of like getting common denominators. If I times everything in the top by 3, and I times, oh man, this pen's exploding, everything in the bottom by 4, what I end up with is two separate equations. I get one where I get negative 12u equals 30 minus 9v. And notice this is the same equation as this. Right? All we did was times everything by 3. It's the same pattern. We did not change the problem. And here timesing by 4 gets me another negative 12u, 20v's, and 88. Now, if I were to subtract these, I would eliminate u. Negative 12u minus negative 12u, anything minus itself is 0. So that's nothing. And that'll equal, when I combine like terms, 30 minus 88, because again, those are the like terms here. Can't subtract 20v's from 30. 30 minus 88 I can do, though. That's going to be negative 58. And negative, don't forget the negative with that 9, negative 9v minus 20v's is negative 29v's. So the question is, what number do I subtract from negative 58 to get 0? Well, the number I subtract is negative 58. So how do I make this equal negative 58? Well, when v is negative 2. Because negative 2 times negative 29 gets me positive 58. And positive 58 minus 58 would be 0. So we found the solution for v that works for both. Question is, what will u be? Well, I can use either equation, because again, they're both going to have the same solution. I'll use the top. We know negative 4u equals 10 minus 3 times v, and we know what v is now. So this simplifies to 10 plus 6, and of course 10 plus 6 is just 16. The question becomes, what times negative 4 is 16? Well, it's clearly got to be a negative number, because a negative times a negative will get us a positive. And you'll learn later that that's not always the case, but for the most part it is. So what number times 4 gets me 16? 4. So negative 4 times negative 4 will get me 16. So our solution for both equations is negative 2 and negative 4. Negative 2 for v, and negative 4 for u. That'll fit both patterns. Now we are nearly done. We've only got one more page of intermediates. And again, with everything bleeding through, I think I'm going to use a piece of paper. These look really awful, but the good news is that the problems don't change. It's just the numbers in the problem. So I'll read this out loud because I know it's hard to read with all the bleeding through. Tweedledum says, so he's talking, Tweedledum is talking, he says, the sum of your weight. Well, the sum means we're adding. So the sum of your weight, he's talking about somebody else's weight. We'll call it B. The sum of your weight and twice mine, so he's talking about himself, let's call himself A. Twice mine means double his weight. So the sum of your weight and twice mine is 748. Tweedledee says, so this is the other person, that's who Tweedledum was talking to. So Tweedledee says, contrary-wise, the sum, and again we're talking about sum, of your weight. So he's talking about his brother Tweedledum. Remember, Tweedledum is A. The sum of your weight, again, talking about Tweedledum, and twice mine. So he's talking about himself now. He's B. Is 749. If they're both correct, how much do they weigh together and how much do they weigh individually? So in other words, we want to find out what A plus B is, because that's what they weigh together. And we want to find out what A is, and we want to find out what B is. Well, this is a linear system, right? We have two patterns. And the question is, what weights for Tweedledee and Tweedledum obey both patterns that they describe, right? One where it's twice your weight plus mine, and one where it's my weight plus twice yours. Well, using elimination or substitution will get us the answer. Right now, if I used elimination by subtracting or adding, nothing would go away, because remember, we'd combine A's and we'd combine B's. So nothing would go away. I could multiply to make that happen. But instead, I think I'll go back to substitution, because it's been a while. I'll use the bottom equation. Let's get A in terms of everything else. Well, if I do that, I subtract 2B's. And of course, there's still a positive 749 over here. So that's A in terms of B and everything. But that's not an answer for A's weight. I just know how it relates to B, which is nothing I didn't already know. Just a different way of looking at it. So I take that and plug it into the top equation. Remember, plugging it into the other equation. I get B plus 2 times whatever A is equals 748. And A in terms of B is negative 2B plus 749. Now, what does this do for us? Why is this a good strategy? Substitution is a good strategy because instead of having an equation with two variables in it, where there's lots of numbers that might work, as we saw on like one of the first problems on the first page, this gives us an equation where there's only one variable, and there should only be one number that gets us 748. So if we simplify by distributing, we're going to get negative 4b here, and then we're also going to get double this. So that's 1400 plus 100 minus 2. So that's 1500 minus 2, which is 1498. If we combine our b's, because they're like terms, we can think of it as negative 3b instead of b minus 4b. Now what I'm going to do now is I'm going to subtract 748 from this, because that's easier for me to do in my head. Looks like I'm going to get 750. And I'm going to add the 3b to the other side. So it looks like 750 is 3 times b's weight, which I believe is Tweedledee. So what times 3 gets me 750? Well, 3 times 25 gets me 75. So 3 times 250 must get me 750. So b's weight must be 250 pounds. Well, if we know Tweedledee's weight, we can figure out Tweedledum's. Because here it says Tweedledum's weight is negative 2 times Tweedledee's weight plus 749. So I know that the weight I'm looking for, A, is going to be equal to negative 2 times B plus 749. And now that we know that B is 250, we can actually figure out the value of A. So that's negative 500. So negative 500 plus 749 gets us 249. So Tweedledee and Tweedledum are 1 pound apart. The other word problem, again, the numbers change, but the words don't, might be a little bit easier. My parents started a small farm after they retired. On their farm, they have chickens and pigs. In total, there are 126 animal legs among the chickens and the pigs, and there are 47 animal heads. How many chickens do my parents have? So let's define some variables. C is going to be the number of chickens, because that's what we want to find out. But there's another unknown, the number of pigs. We don't really know how many pigs they have. What we do know is that there are 47 animal heads. So think about it. Each animal should have 1 head. So the number of chickens, that's C, plus the number of pigs, that's P. Together, the number of animals should equal the same thing as the number of heads. So we know that C plus P, even though we don't know what C and P are, we know it should add up to 47. We also know that we have 126 animal legs. Well, if each animal had 1 leg, then we'd have C plus P also equals 126, which wouldn't make any sense for a couple reasons. One, we already said C plus P is 47, but also because we know that these animals should not have 1 leg each. In fact, if you knew that there were 10 chickens, you could probably tell me that there are 20 legs, because you know the number of chicken legs is 2 times the number of chickens, because there's 2 legs per chicken. And if you take the number of pigs, you could times it by 4 to find the number of pig legs. So we have chicken legs now, pig legs, and if we add them together, we get the total number of legs. So this is a linear system. We can find a solution that fits both patterns. A number of chicken and pigs that fits this pattern, that they add up to 47 total heads, and that they fit this pattern, that the number of legs will add up to 126. So what number of chicken and pigs fits this sweet spot? Well, for this one, I think I'm going to do elimination. I notice right away if I times the top all by 2, that becomes 2C. This becomes 2P. And 47 doubled is just 50 doubled minus 6, which is going to be 94. So this is the same equation we had before. 2 times the number of chickens plus 2 times the number of pigs will get you a total of double the number of heads, right? If we double the number of animals, we get double the number of heads. So it's the same relationship. It's just a different way of looking at it. And what's nice about this way of looking at it is that if I subtract these relationships, subtract these equations, I will eliminate 2C. 2C minus 2C is 0C, so it goes away, it gets eliminated. And then if I have 2P minus 4P, I'll get negative 2P. Be careful with that minus. 2P minus, because that's what we're doing, 4P is negative 2P. 94 minus 126 is going to be negative 28. So the question is, what times negative 2 gets me negative 28? Well, 14. So it must be true that there are 14 pigs. That's the number of pigs that will give us the right number of heads, and it'll give us the right number of legs. So what does that mean for chickens then? How many chickens will we have? Well, remember from earlier, I know that the number of chickens plus the number of pigs, which is 14, should equal 94. Or sorry, not 94, 47. That's the doubled amount. So what number plus 14 is 47? Well, they must have 33 pigs, or 33 chickens, I should say. So we have 14 pigs and 33 chickens. That'll get us 126 legs total, and it will get us a total of 47 heads. Now, there's one thing I forgot about this last Tweedledum problem before we go away. They want to know what A and B equal, and we did that, right? We found that A and B are 250 and 249. So what's the sum of A and B? That's what they wanted to know. How much do they weigh together? Well, since they're both 250, except one's one lighter, 250 and 250 is 500. But because one is 1 pound lighter, we're not going to get 500. We're going to get 499. And that's what A plus B would equal. All right, so that's it for all the basics on Chapter 5 and Chapter 4. Hope this helped. I've got this right here, which I will leave for tomorrow. And if you'd like a copy of it to use as notes, just let me know, and I'll make some for you.